Can you really run a 685 billion parameter model on a single GPU and a beefy CPU? Well, in this video, we are doing exactly that. In this tutorial, I'll show you how to get DeepSeek V3-0324, which is a mixture of experts large language model with huge number of parameters running on Ubuntu 22.04 with just one NVIDIA RTX 4090 and a beefy CPU with a ton of system RAM. We'll use an official K-Transformers Docker image to make the setup a breeze. Now, why DeepSeek V3-0324? Well, this is the latest upgrade to DeepSeek V3, and it's a major one. It outperforms all the previous versions on reasoning and coding benchmarks by a significant margin. It improves function calling ability and supports neat features like structured JSON outputs and tool invocation. Essentially, it rivals top closed source models while staying open source. Its new FP8 tensor technology slashes memory usage, making it accessible on standard hardware. No more need of a server farm to experiment with these ultra-large models. The motivation here is simple. Push the limits of what you can do with off-the-shelf hardware. Our setup, which is an RTX 4090, an Intel Xeon 8480 Plus like processor with 56 cores, 112 threads, an Intel QYFS engineering sample, with 512 gigs of DDR5 ECC RAM on an Asus Pro WSW790 Sage board. Now, this might sound high-end, but it's essentially a single workstation, which is a far cry from a multi-GPU cluster you would expect for a 685 billion parameter model to run on. With FP8 hybrid quantization and K-transformers, this single machine is up to the task. So if you are an AI researcher, a machine learning engineer, or just a curious YouTuber like me with access to such a hardware, then stick around. I'll walk you through the entire process, step by step, with real-world tips on performance and pitfalls. All right, let's dive into how all this works under the hood before we get our hands dirty with the demo. DeepSeek is a mixture of experts model. It has a massive number of parameters, just under 700 billion, but only a subset of them, which is about 37 billion, are active for any given token. So think of it like a group of experts in a network where only some experts fire each time. And this design gives it the huge capacity without always using all the weights at once, which is one reason we can even think of running it on a limited hardware. The model employs a multi-head latent attention, or MLA, and other tricks from DeepSeek V2 to keep the inference efficient. The V3-0324 update brought further training refinements, better load balancing between experts, and a multi-token prediction objective, which eventually led to boosting of the performance on complex tasks like reasoning and coding. So in plain terms, 0324 is smarter and more efficient than the original V3. So how do we compress a beast like this to fit into a 24 gigs GPU? The key over here is FP8 plus GGML hybrid quantization. So DeepSeek V3-0324 introduced an FP8 tensor format, which is 8-bit floating point. For certain parts of the model, it uses this FP8 tensor format, which dramatically reduces the memory usage while preserving the accuracy. Now, the attention mechanisms and the shared layers of the model run in FP8 precision on the GPU. These are the components every token passes through. Running them at 8-bit floating point offers a sweet spot, far less memory than 16-bit, but still enough precision for these critical computations, much better than pure 4-bit. And when these computations happen on GPU, then they are super fast for us. Now, K-Transformers has a custom FP8 GPU kernel also to accelerate these layers, which is really amazing. The expert layers, which is the mixture of expert parts that make up the most of that 685 billion parameters, they remain in the GGML quantized format, the 4-bit in GGUF, and they are kept in CPU memory. Only the necessary experts weights are used for each token, and they are computed with high parallelism on the CPU. By keeping these in 4-bit, we massively save on memory. So you'll need on the order of a few hundred gigs of system RAM to hold such a model. And in our case, we have 512 gigs of RAM, so it easily covers that. Now, this hybrid approach is the key. It brings GPU acceleration to the parts that bottleneck the generation speed, which is attention, and keeps the GPU memory footprint low, leaving a bit of headroom on the 24 gigs card. You must have a GPU with FP8 support. The RTX 4090's Ada Lovelace architecture does support FP8 math, which is why this is a bare minimum GPU that I would use over here for our purpose. I think RTX 4080 would work too, but 4090 would give you that headroom. Now, older GPUs without FP8 would have to fall back to slower or less efficient methods. 3090 would work too, but you will not see the performance gains that you will see with 4090 over here. So in summary, FP8 hybrid quantization gives us the best of both worlds. The speed precision of GPU FP8 where it matters, and the extreme compression of 4-bit quantization for the rest. That's how DeepSeek V3-0324 became runnable on a standard hardware. Without FP8, you'll need way more GPUs or memory to run this model. So this is where it is just perfect for our hardware to run DeepSeek V3-0324 with this hybrid architecture. Now, who orchestrates all this complexity? Of course, K-Transformers. This is an open source inference framework from the KV Cache AI team designed specifically to optimize large language models like DeepSeek for local deployment. It handles all the heavy lifting, which is integration of FP8 kernels. K-Transformers natively supports those FP8 GPU kernels for DeepSeek's linear layers. We don't have to manually fuss with low-level code. It's all built in. This is the big part of why we use the official Docker image. Everything is pre-compiled and ready to go. It automatically manages moving data between CPU and GPU. The attention and the shared layers are executed on GPU and the expert layers on CPU, token by token. It uses multi-threading to utilize all available CPU cores during those CPU-bound parts. And today we are going to see how we'll be using 32K of context limit in their latest Docker image, official Docker image available. So for our purpose, 32K context is a huge win. And imagine feeding very long documents or chats without even running out of context or worrying about asking follow-up questions. We'll emphasize this long context capability when we run the model. Now, K-Transformers is built for performance. In this tutorial, we'll stick to default single GPU usage. We will, however, experiment with some of these parameters like CUDA graphs and thread counts, and we'll see how our performance is optimized with these parameters. All right, the Docker image. It just works. K-Transformers team provide us an official Docker image that packages all necessary dependencies. So we are talking CUDA, PyTorch, K-Transformers, and this is a lifesaver. No compiling giant libraries, no environment nightmares, none of those on your machine. The image even comes in two flavors. One is optimized for AVX 512 CPUs, and another one for older AVX2. So you get the best performance for your hardware. Given that we have Intel Xeon 8480 Plus clone, which is the QIFS engineering sample version of our CPU. It supports AVX 512 format, and we'll use that in our build today. Using Docker also means that this setup is reproducible and you can follow along with the exact same environment as I'm using. So in short, K-transformers plus Docker abstracts away a ton of complexity. We can focus on using the model rather than fighting with the build errors, and we still get to squeeze every drop of performance from our 56-core 112-thread CPU plus RTX 4090 combo. Okay, that's the game plan. Huge model, tiny precision, smart software. Now, let's put this all into action step by step. All right, let's get our hands dirty and I'll walk you through the exact commands over here. Make sure you are running on Ubuntu 22.04 with Docker, NVIDIA drivers, and NVIDIA Container Toolkit installed. So first, let's create a clean project directory to keep everything organized. So you will want to create one folder for downloading the V3-0324 FP8 model directly from DeepSeek AI, another one for downloading the Q4 GGUF from Unsloth, and the third one where you'll have the merged hybrid model. Once you have these three folders created, we'll need the official FP8 weights from DeepSeek AI on Hugging Face. Then we'll need the GGUF version Q4KM version from Unsloth, and specifically this quant because that provides a perfect balance for us. Unsloth does a fantastic work with GGUF quants, and we'll just use the Q4KM GGUF files over here. Now, building the hybrid model with Docker is the core of our hybrid setup. We'll use the official K-transformers Docker image to run a Python script that merges the FP8 safe tensors and the Q4KM GGUF file into the hybrid format K-transformers needs. So to do that, we'll pull the latest image from the Docker Hub, and we'll get this from approaching AI/K-transformers repo. And the image that we'll use is AVX 512 tagged image because we are using the Xeon 8480 Plus, which does support AVX 512. And this definitely provides better CPU performance. So let's not use that AVX2 unless and until you really have an older processor. Okay, now K-transformers does provide a script called merge safe tensors gguf.py, and we'll need to run this inside the Docker container, giving it access to our downloaded models, and then instruct it to place the saved model in the appropriate path using this command over here. Now, the classic Docker trap. When we merge the models using our merge script ran inside the container, it is running it as a root user. And it has created these merged model files in our mounted output directory as the root owned files. So let's change the ownership back to your user. And then you'll need to use chown and recursively change the owner and the group for the files in the directory. All right, with the model data ready, once the correct image is pulled and run, we this time can run it using -itd. And let me actually go over all these components one by one. So -GPUs tells which particular GPU we want to use and which GPU we want our container to have access to. -V is the volume mapping which mounts our host folder with the model weights into the container at the path/models. And this is very crucial. It lets the container read the large model files we downloaded, and we mount the whole models directory, but we specifically use the DeepSeek subfolder inside it. --name K-transformers gives the container a friendly name so we can refer to it later on. -itd runs it in detached mode, but with an interactive TTY allocated to it so we can execute into it next. Now, the image name tag is approaching AI K Transformers latest AVX 512 as we had pulled earlier. Now, let's just run this and we have a container started in the background. And to use it, we'll execute into it with a bash shell now. So this is the command, and now our prompt is inside the container. And you can see the root, container ID, and workspace next to it. And we are ready to run the model now. So now from inside the container shell, we will invoke the ktransformers server command. And this script is provided by ktransformers to run the model in the server mode. And we need to point it to our merged model architecture and weights and apply the FP8 optimization configuration appropriately. And you can see that we are providing the model path, and this specifies the base model architecture to use. And here we are pointing it to correct DeepSeek V3 model repo on the Hugging Face. The config and the model definitions are downloaded on the fly. So DeepSeek V3 and 0324, they do use the same V3 architecture essentially. And ktransformer knows how to load it. So this will allow the script to download or use the model config automatically. So just use it the way it is coded over here. Now in the GGUF path, we have to provide the hybrid FP8 model that we had just generated. And this is the directory containing our merged FP8 GGML weights. We mount it in the container so that the path is visible and it is picked up by our ktransformer server. Now, even though it is safe tensors file format inside, we provide just the folder path and not the file name. The script will find the safe tensors in that folder. And this path corresponds to our quantized experts. So don't be confused by the name. It is our hybrid weights folder over here. Now, our optimized config path is referring to the YAML config that tells ktransformers how to apply the hybrid quantization for DeepSeek V3. It's basically a recipe saying use FP8 linear layers and GGML experts. And this file does include all the different details that ktransformers will need. And that is why this is included in the ktransformers package inside the container itself. So we can just reference it by the path in the repo under the ktransformers optimize rules path from inside the container itself. And by providing it, of course, we ensure that ktransformers knows that we want the FP8 GPU kernels and that the experts are offloaded to the CPU. The CPU inference is number of CPU cores plus 1. And this is the number of CPU threads for inference. The recommended is 57 over here, as we have 56 cores. Our Xeon will heavily utilize the CPU for these experts layers. So now using all 112 hyper threads isn't usually beneficial due to memory bandwidth constraints. So sticking to cores is just fine over here. If let's say you had 16 core CPU, you would use CPU infer as 17. So when you run this command, ktransformers will start loading the model. The console output will inform you as it loads the GGUF experts into the memory and sets up the FP8 kernels. Now, the first run triggers some JIT compilation for optimized kernels. So the very first run might take a few more minutes before the model is ready or warmed up. This is a one-time hit. Subsequent runs reuse the compiled parts, so you don't have to wait for that long for subsequent runs. So now, eventually, you see a prompt in the terminal indicating that the server is ready, and that means DeepSeek V3-0324 is up and running. All right. And there we have it. a full run through of getting DeepSeek V3-0324 FP8 hybrid running on Ubuntu 22.04 box with Docker with OpenAI compatible API endpoint. We covered the motivation, huge model, tiny precision, high performance, the technical magic, FP8, mixture of experts, K-transformers, a step-by-step guide, debugging some common issues, and even some performance tuning. It has been a long tutorial, but hopefully a rewarding one for those of you who are adventurous enough to try this out. So just to recap the highlights, using FP8 hybrid quantization, we fit a 685 billion parameter in less than 24 gigs of VRAM for its attention layer with minimal loss of accuracy. And that's a big deal in model compression. The official K-Transformers Docker image simplified the install greatly, and the framework gave us an extended 32K context and a solid speed on a single GPU. Our hardware 4090 plus 56 core 112 threads Xeon was pushed to its limits, and it delivered about 10 tokens per second throughput with under 24 gigs of VRAM usage, which is an impressive for such a massive model. Now, DeepSeek V3-0324 itself showed why it's an exciting model. Its improved reasoning, coding, and even function calling abilities over the previous version, all accessible to the community for free. This kind of setup opens up opportunities that you can host your own ultra powerful chatbot, run experiments in AI research that were previously out of reach locally, or integrate this model into applications like coding assistants, data analysis without relying on external APIs. Granted, not everyone has a spare 4090 and a beefy CPU laying around, but high-end PC builders, labs, or enthusiasts could replicate this very easily. And as hardware gets better and the models get more optimized, this will only become more feasible. Now, if you successfully get this running, try engaging DeepSeek V3-0324 in your field of interest. Ask it coding questions. Have it write an essay. Test its reasoning with puzzles. It's not every day you have a 685 billion parameter model at your fingertips. Also, consider joining DeepSeek or K-Transformer communities to share your experiences and learn some more tips and tricks. They have an actively improving community over there, and they do have a multi-GPU support, which is very promising. There is a 0.3 version of K-Transformers where they have attained very high speeds. It is not yet open source yet, but I'm looking forward to it. If you found this tutorial helpful, feel free to give it a thumbs up and subscribe for more deep dive for AI content. I love exploring cutting edge setups, and your support helps me keep doing it. Thanks for hanging out for this long with me through this technical journey. I hope you enjoyed it, and as much as I did, I would like you to build such a machine also. If you need any help, please drop a comment. And until next time, happy inferencing and keep pushing those AI boundaries. I'll see you guys in the next video.